All right, London, feeling pumped. Thanks for that wonderful introduction. All right, let's do this. So I presume you're all familiar with polars if you've come to an advanced polars tutorial. So let's start with a bit of motivation. You know, morning, 11 o'clock, I didn't sleep too well, so let's get the energy levels up a bit. What do we do when polars isn't enough? So here's a question which I saw asked on Stack Overflow some time ago. Somebody has some data ordered by time. They've got some numbers. They want to do a fancy cumulative sum, but it's not just any cumulative sum. They want to cumulatively sum numbers, and when they go above a certain threshold, they want the cumulative sum to reset. And according to this question, the threshold was 5. So just to make sure we've understood the assignment, let's just work through it. So 1 plus 2 is 3, then 3 plus 2 is 5, and then 5 plus 2 is 7. 7 is greater than 5, so after that, the cumulative sum resets to 2. Then 2 plus 1 is 3, 3 plus 3 is 6, but 6 is greater than 5, so the cumulative sum resets again, and so on. Now, they didn't tell us what they wanted this for. I'd be very curious what they need such a fancy function for, but nonetheless, sometimes we do have unusual use cases. I can think of quite a few that I encountered back when I had a real job doing data science. And typically, what I would do in those cases would be something like iterate over rows in Python. And anyone who's tried doing this will know, yeah, it can work if you've got a teeny tiny data set that you can barely see. But the moment you start scaling out and working with millions, billions of rows, then you're going to be stuck waiting for a while. Another solution that people like to use is a number, which in polars has some issues. Because anytime you've got a series with missing values, number isn't going to support that. So I'm going to show you a super secret, magic, life-changing method today, which you can use to solve this kind of problem efficiently, and it'll be easier than you think. The solution is to write a polars plugin, and you just need to follow the following 6 simple steps. So first of all, I recommend using the cookie cutter template provided at the bottom of the page. Step 2 is to pip install polars and Maturin. We're not going to get very far with polars plugins without polars, and Maturin is what we use to publish and build mixed Python and Rust packages. Then comes the hard part, writing a bit of Rust logic, but my claim is that it's easier than you think, and we'll cover a bit of that today, especially if you're just trying to beat Python implementations of numeric functions. You don't need much Rust knowledge. You can just kind of write it as you'd write Python and then let the compiler tell you what you've done wrong and get something together. Polars itself deals with a lot of the complicated parts for you. After that, you'll need to register your Rust function in Python. Then you can compile your code, and very important, step 6, do not forget this one, celebrate, because congratulations, you have a Rust plugin. And these slides are an excerpt of a talk I gave at PyData Berlin when I then put a timer for 5 minutes and showed that you can actually replicate this Python function as a polars plugin in 5 minutes. And today, you are going to get the keys to the Lamborghini. You're going to know how to do this yourself. So step 1 is to install the cookie cutter template. Now, this was technically in the description of this tutorial. So let's have a quick show of hands who followed the prerequisites and has the cookie. Oh, wow, lots of people who do their homework here. Wow, your teachers must have been so proud of you at school. For anyone who didn't do that, well, you can navigate to my GitHub page. If you give me a star, it won't affect your understanding of today's tutorial, but it will boost my ego, depending on whether or not you want to do that. Give it a star or not, and then you can install this cookie cutter. So starting from this cookie cutter, we're going to start from the simplest possible example. We're then going to modify it and do different things, and I would like this session to be somewhat interactive, so if you've got a burning question, then you don't need to wait until the end. Just put up your hand, and yeah, I'll try to take it. Or don't put up your hand. Heckles are welcome. Let's see how well I handle them. Right, let's do this. I am going to be using NeoVim, not because I'm good at it, but because apparently it makes you look smart. If you follow the first step and download this cookie cutter template, you'll get something that looks like this. So let's take a look at what's inside. Told you I wasn't good at NeoVim. So we've got the cookie cutter will prompt you for a name. So what do you want to call your plugin? So I'm going to call it my plugin, of course. And there's two main folders I want you to focus on at the beginning. We've got my plugin, which contains the Python files. So this is how your user is going to interact with it. And then we've got src, and this is where the Rust code is. We're going to have to deal with a bit of both. And but also, there's a handy little run.py file, which contains the world's fastest pig Latinifier. Anyone familiar with pig Latin? Okay, lots of enthusiastic nodding. Not sure why such enthusiasm, but it's good to see. Maybe you answered no to the previous questions and you were finally like, yes, I know this one. Either way, it's a little game that children play whereby you take words, you remove the first letter, you put it at the end of the word, and then you add AY at the end. Now, it is possible to do this with Polar's expressions, but suppose you're in a context where you need a production-critical pig Latinifier and it needs to be as fast as possible, then I think this plugin is probably the best way to achieve that. So let's give it a quick go. I'm going to activate my virtual environment, and if I compiled things beforehand, this is what happens. And this could be you. You could have written that plugin. So let's take a look at what it does. We're just going to try to make sense of this sample plugin that comes with us in the cookie cutter, and then we'll try to work through some simple examples. It might also be fun to try taking some requests for plugins from the audience, and I could try live improvising coding them. And if this is not educational, I hope it at least provides you entertainment in the form of Schadenfreude. Let's take a look at pig Latinify. So on the Python side, this is what it looks like. So we take in an expression, and into expression, this is the type int, which in Polars means something that's either an expression or it's convertible to an expression. So if we go back to the run file, you see that here we passed English. Like, we didn't have to do pl.call. We didn't have to do pl.call English. So Polars can take a string and convert it to an expression for you, unless you ask it not to. Right. Then, what we're going to do is we're going to call a handy function called register plugin. Now, people sometimes complain about Polars having breaking changes, and the mechanism by which plugins are registered is no exception. It did change in version 0.20.16. So in the cookie cutter template, a little helper function is provided which works across different versions of Polars. If you're a library author, you probably want your plugin to be available to people working with different versions of Polars. So this can handle the cross-version compatibility for you. And we're going to have to pass a few things to it. So args, these are going to be all of the columns, all of the expressions which we want Polars to work with. In this case, we only pass a single one, which is the English column. Just this is not pig Latin. Symbol, this is the name of the function which we're going to register on the Rust side. So if we look at expressions.rs, here we've got pig Latinify. That's what Polars is going to look for. So it needs to match. Then isElement-wise, what does this mean? This is used to trigger fast paths in Polars. We're going to look at an example of where this really matters later, but isElement-wise, as it says on the tin, it's does the plugin work row by row? For pig Latin, each row can be considered independently.
it's not like to pig Latinify row 3, you need to consider what happened in row 2. Whereas for the really custom function, which this Stack Overflow asker asked, this one is not element-wise. What comes before really matters. So yeah, need to make sure to set this correctly. And then lib. What's lib? So you see here, it's this get shared lib location. So when you compile the Rust code, it generates this .so, this shared object file, here inside your Python directory. So Polars just needs to know where that file is, where to look for it, and that's where it's going to look for this particular function. Right. Yeah, how are we all doing? All right, got a question, Jérôme.
Yes, Marco, wonderful. Is it also possible to let the plugin at this point register an expression namespace so that you can use it as a method instead of a function?
Yes, so I like to separate out the two concepts. Just an expression namespace. I like to register the concepts because it's one thing to define a plugin, which is a function which can produce an expression. And it's another thing to register a function as an expression namespace. So there is a functionality to do that in Polars. Now, personally, I'm not very good at typing, so I like to rely on my IDE to help me as much as possible, and that includes autocomplete and type hints and all of that. And my big gripe with this register expr namespace and all of this extending the API section is that it doesn't work with MyPy, it doesn't work with autocomplete and all of that. So if, like me, you can't type, it's a bit annoying. So my personal suggestion is just to create self-standing plugin functions that people can just use. But yeah, if you want to register them like this as a namespace, you can do so. And yes, it is possible to do so at this stage, but I'm not going to shoot myself in the foot by doing it. If you make a plugin available to people, then I would like to ask you to make it available. If you want to make it available like this as a namespace, I'd like to ask that you also make it available just as a function so that we're not obliged to use the non-type hinted version. Cool. Any other questions?
So I just want to clarify. Like, so the namespace you can create it with pure Python, but like you can also create it with what we're doing now with Rust, and so it works both ways, right?
So the namespace, I think you can only register it from Python. Whereas what we're doing from Rust is we're creating a function. So just to clarify the difference. So in my case, I've made a function pig Latinify, which is inside, sorry, maybe half the room couldn't hear me up until now. Is this better? Okay. Right. I guess the previous speaker was a bit shorter. So.
Create a module in Rust, right? Using PyO3 and then just like use that, and then in Python you register that as a namespace.
Tell me that you've given PyO3 tutorials without saying you've given PyO3 tutorials. I don't know, I presume you can, but just to demonstrate the difference here. So what I've done here is just from my plugin import a function, and then I'm just calling the function. The alternative way would be, actually let's not comment it out, would be to do this pl.call english.mp.pig-latinify, and yeah, if you're ever at a Polars themed dinner and you want to get people talking, ask people which of these two is more idiomatic in Polars. You'll get some very strong opinions, but I'm team this one. Right. Cool. Now, let's take a quick look at pig Latinify. I think this one's a little bit complicated as an example to get started with, so we are going to look at a simpler numeric one after this. Numerics also have their complications, but let's do things one step at a time. So, what it takes in is a slice of series. Now, a series in polars is untyped. It does not have to have a type associated with it. But each series is backed by a chunked array, and that chunked array has to have a specific data type. So what we're expecting here is to get a series which is backed by a string chunked array. Let's give a quick demonstration of this. So if we make IPython, if we make a series like this, foo bar PyData London, then can see underneath, yeah, it's backed by some crazy stuff. That's not what I wanted to show though. I wanted to show the chunks. Yeah, I get chunks, that's it. All right, so it's backed just by a single string chunked array. And, but there could be multiple ones. Like if we take append and we make a series with PyCon DE or something like that, then now we've got two chunks. We've got the first ones and then the second one. And each chunk, it's data that's going to be contiguous in memory. Right. So we're first just going to make sure that we've got something that is of type string. And then we've got this question mark. If you're not familiar with Rust, this will just propagate the error up to the user. So it's like if this really was a string chunked array, we're going to assign that to this variable. And if it wasn't, we're going to propagate the error up to the user. So for example, if we go back to run.py and we make some numbers column like 1, 3, 2, 5, 4, and then run it, and then pass that one instead, numbers. All right, then polars is going to propagate that error up to the user saying the plugin failed with the message invalid series data type. We expected a string, but we got an int 64. Right, next, what happens here? So generally, you don't want to write your own functions to iterate over these chunked arrays. You want to use what polars is already providing you, especially when you're working with strings, which are more expensive to store than just purely numeric values. So what apply to buffer does is it expects a function, a closure, which takes two values. So one is the input string, so that's the value that we're iterating over, and another is an output buffer, which we are going to write our output to. So what we're going to say is, if there is a first character, we're going to move that character until the end, and then we're going to append a y to it, and then write this to our output string. Now, I said that today's talk would be suitable for people new to Rust, and some of this indeed looks a bit complicated. My recommendation is, if you're working with strings, just copy and paste this and adapt it to your needs. On the other hand, when we're working with numeric data, then that's a lot cheaper to copy and work with. Don't need to do a heap allocation for every new integer which you assign. So that's going to be a lot easier. I say let's move over to integers and let's look at how we can make our own absolute value calculator. Not particularly exciting, but we need to walk before we run. And to make this, we're going to copy the piglatinify, and we're going to make a function called absolute value i64. Now, let's first change the output type to be int64. We're only going to start with a plugin which works on 64-bit integers. Once we've done this, we're going to look at making it generic over input types. Then we're going to change string to i64. We don't actually need this type annotation, so let's get rid of it. And then let's get rid of this complicated logic. And we're going to say let out int 64 chunked equal to CA, and then I'm going to use apply values. And for each input x, we're just going to take x.abs, and that should be all we need to do. Simple? Yeah, simple. Right, let's do this on the Python side as well, just to convince you that it actually does work. Pig latinify, let's make this abs I64, change the name of the function, and the rest can stay exactly the same. Yeah. But we are going to have to do something which might be unusual to you if you're used to only ever working with Python code, and that is to compile. So I'm going to do mature in develop. This is a slightly faster way of compiling. If you're looking at benchmarking, you should use mature in develop -- release. It'll take longer to compile, but it'll be fast to run. And presumably, if you've come to a Polars talk, then you have some interest in things running quickly. Or you just like the API, I'm not sure. Anyone here came for the speed but stayed for the syntax? Luca, all right. Okay, let's modify run.py to also use our amazing abs I64. And then let's import my plugin as MP. Let's remove that comment. And then I'm going to make a separate line in which I make the absolute value. Abs numbers is going to be mp.abs I64 numbers. And maybe let's make one of them negative, otherwise it's going to look really, it's going to look like we're not doing anything. And we don't need to compile again because we only changed the Python code. You only need to compile if you're changing Rust code. So now let's take a look at what happens. Lol. Oh, it's because I had the intentionally wrong example to show you that the error was getting propagated. Let's change that to English. And now, all right, we've got our own plugin which calculated some absolute values. Now, let's try inserting a null value. And let's go back to the definition. So now that there's a missing value, there's a none in there, what's going to happen? Playing with fire here.
Nan.
We're going to get a nan. This isn't pandas, bro. So maybe just to clarify that remark, I should probably say something. Let's have a little pandas detour. Now, I think we're generally discouraged from talking down on open source projects, but I am in fact a pandas maintainer, so I think I get a free pass on criticizing pandas. So SPD is going to be s.series123, and then let's make SPL pl.series 123. Now for the pandas one, if we do something like diff, so we take each value minus the previous one, then pandas, because this series is backed by NumPy, it can't store missing values, and well, NumPy can't either, but NumPy float arrays can store nan, and so nan has historically been used as a missing value indicator within pandas. But Polars, Arrow, R, they make the distinction between nan and null. So nan is just a floating point number which comes from illegal mathematical operations like dividing 0 by 0, whereas NA or null, missing, it's just missing data. So in Polars, if we have something like 1, 0, none, and we divide it by itself, then yeah, what are we going to get? Quick. A bit louder. So was that one nan or one nan null?
Null.
One nan null.
All right. All right, you win a Polar sticker. And yeah, indeed we get one none and null. Yeah, they're different. So I think this can save you from some mistakes in sometimes. Like if you do drop nulls in polars, it's only going to drop the null values. And then if you've still got some nan, it's because evidently you must have done some illegal mathematical operation. And you probably want to know about that. But how does polars store these null values? That's actually very closely linked to the question we're trying to answer here. Because if we go back to our example, we've now got a missing value here. Yet here we're just doing x.abs. Like, what is none.abs? Like, you can't take the absolute value of just nothing. So what happens? The null value is preserved. Why is that? I'm curious in hearing people's guesses. Why did the null value get preserved, even though here we said just apply values? And for each value, we're just doing x.abs. Any guesses? You might win another Polar sticker. You might not. Random rewards. Hey, am I appearing in a TikTok? No? Ah, disappointed. Oh, sorry. You're correct that there's no .abs on null. Yeah. So, well, what we can do is we can use the best debugging technique in the world. Yeah, which is print statements. And yeah, this dbg macro, it's just a fancy print statement, but it also shows you the line that you're on. So let's take a look at this. And also, I'm going to be really mean. Let's say df equals df.with columns pl.col numbers minus 42. Yeah. All right. And now, let's go back to the terminal. So now if we run this, it should print out the exact number that it's calling abs on each time, which in this case is going to be
It's not going to call abs on null.
no. What is it going to call abs on? What's the answer? What's the question? Yeah, that's more complicated, but what's the answer? Any nerds in the house? If you don't know the question and somebody asks you what's the answer, it's probably exactly. So if we run, oh wait, we need to compile, sorry. Yeah, that's the thing with Rust, compile times. I'm actually thinking of trying to build my own PC to get compile times down. The alternative is having more time to shitpost on LinkedIn. Not really sure what's best. Yeah, I don't know. Because Polars is too big. Yeah, right. So if we look at the numbers that it was called on. So here we had minus 41, and it printed minus 41. Then minus 39, and it printed minus 39. Then we had null, and it printed minus 42. And then minus 47, minus 47, minus 38, minus 38. So when it encounters a null value, it's actually just computing the absolute value on whatever physical number happens to be behind the null value, which could be absolutely anything. Like, you should never rely on it for anything. And this is why I discourage using a number to speed up your Polars calculations, because it doesn't support missing values. And we can see that here. Like, if we make a series, pl.series, yeah, let's use this one. Let's use something other than 0, 3, and then get buffers. All right, so what you see is 1, 3, none, but actually what's behind this series is 1, 3, 0. And then separately, there is a bit mask
which records true, true, false. So it records whether each element is valid or not. And then what can be displayed to the user is 1, 3, and null. Now, in the case of our plugin, where did the plugin go? Told you I wasn't very good at Vim. Okay. Feels like I've got something open inside of something else. No, it should be good. Okay, so in the case, sorry, I need to remember to speak into the mic. So in the case of polars, so here apply values, it's applying the absolute value to every single value, including the values that are behind the null elements. Right, got another chance to win a polar sticker. So it seems like polars just took all of the values, like 1, 3, 0, whatever physical value happens to be there, even whether it was missing or not, and it applied the absolute value calculation on it. Why did polars do that? Like, why could we not have said, for each value, let's check whether it's valid or not, and for the missing ones, we won't take the absolute value? Why? Yeah,
it doesn't matter.
It's true, it doesn't matter, but for performance reasons, which would you expect to be faster? Like that we just apply the absolute value to all numbers, or we only apply it to the ones that aren't missing?
Keep checking, so it's faster.
Exactly, checking. So in this case, the operation that we're doing, x.abs, like you're just flipping one bit, it's super cheap. And in fact, checking whether, like the time it takes to check whether a value is missing or not, it's more expensive than just flipping the switch for all of the elements. So it's, in general, when you're doing low-level code like this, then if you can keep your code really simple functions without if-then statements, then it's going to run a lot faster. Right. However, you might be interested sometimes on dealing with missing values yourself. Like maybe you don't want to preserve missing values, or maybe the logic you want to apply is really complicated, really expensive, like you need to call into a third-party library that does some parsing and some complicated stuff, and in that case, you probably do want to skip over the missing values. If you want to do that, then the function you'll want to use is called apply. So another way to do this would be apply, but now each value x is going to be an option. So what we're going to do, x opt, and let's print this. Right, what am I missing? Oh, I'm missing a map. Right. Live debugging, oh no. This. Right, Rust experts in the audience. What am I? Oh, wait, yeah, sorry, I'm just missing this one. It was kind of telling me, maybe I could have just listened to the Rust analyzer. All right, here we are. So yeah, let's, well, whatever. It'll complain that this one isn't used, but this is another way that we could do it. And let's add a debug statement just to check. So now debug x opt. Let's do mature in develop. And now you'll see that the function only gets applied to the values that are not missing. Once it compiles. Okay, yeah, so now if we look at the debug statements, so yeah, the first version, which was apply values, it prints out all of them. But the second version, which is just apply, whoops, then for each one, it prints some or none. So the first two are some, third one is none, the next two are some. Cool, that's enough talking about null values and branch mispredictions. Any questions about what we've covered so far, or shall we talk about how to make this generic?
Got a question?
The apply value thing, will that also work on like string or UTF-8 types?
Yes, but it's not recommended. So for strings, it's recommended to use apply buffer because that does some smart trick for you. So it'll instantiate a temporary string, and then it just keeps clearing it and rewriting it to that one, as opposed to allocating a new string in every iteration of the for loop. Now, yeah, if you're doing something performance critical, this is something you might want to keep in mind. So people writing books about polars, you might want to note that down. Yeah, the Polars, the definitive guide is coming out. When is it coming out?
November, hopefully.
November. I recommend you all read it when it comes out. It's going to be amazing. And no worries. And but I did get a bit distracted. Where were we? Yeah, right. So, however, if all you need to do is beat map elements in Python, if all you're trying to beat is this, then even just using apply on the strings, just allocating on every iteration, it's still going to beat this. So even the not going to say that even the worst possible Rust code is going to beat Python, but it's not that far off the truth either. Cool stuff. So yeah, any other questions? All right.
The string type is string, right? Not str.
The string type. Wait, sorry, which? Oh, so in Polars, the data type is just a string.
But when you
So-
write your extension, you are kind of treating it as string in Rust, right?
Yeah. So in Rust, what we get passed here in the function is a string slice, but
String slice, okay.
but Polars itself only has the string data type.
Okay.
So like in Polars, if we make something like series, I love PyData London, then yeah, the type, I mean, the repr shows .str. If you do s.dtype, it shows a string, but this is like, as far as Polars is concerned, this is just the Polars data type,
Yeah,
which
but
is just this one.
But internally is str. Okay.
Well, internally, sorry, it's an str in this function, apply to buffer. The argument is just a string slice, but internally, I presume each chunked array needs to have ownership of its values, so each one should be an owned string. I've not checked, but presumably. String stuff is complicated.
Yeah.
So, yeah, in general, if you can't put a time zone on something, I don't necessarily know about it. Where were we? Oh, right. I think there was a question from back here, though. Yes.
Is there a hot reloading like watch mode for maturing so that as you're editing the code, it just rebuilds it?
Probably, but I'm not very good at technology, so I don't know how to enable that. If
Oh, there's a hook that every time you change the source code, you run maturing automatically.
wow.
Yeah, there's a hook. If you go to PyData documentation, actually, there's a hook that you can grab. Yeah.
Oh, wow, okay. That sounds a bit dangerous, though. It's going to do a lot of compiling. Right. Yeah, anyone else?
Was this the accepted Stack Overflow answer? Because I think you can do much better than this, even in Poland, like with relative reducing or something like that.
I can't remember. I think they were doing like some fancy explode, implode kind of things. Yeah, yeah. Can definitely do better than that. That's like a last step resort. Right. Anyone else? Okay, let's try to make this more generic, because currently it only accepts I64. Like if we try to make something like F64, then, and let's make sure to make this a float, then it's not going to be too happy. Whoops. Yeah, it's going to raise. It says expected int 64, but we got float 64.
And this is almost certainly not what you really want. You almost certainly want a numeric function like this to work on any numeric type. So let's learn about how to do that. And a solution you probably don't want is to make 8 different variations of this function, like abs I64, abs I32, and so on. So let's try to make it generic. Let's get rid of this one, which was just for educational purposes. Get rid of the debug statement so we don't see that every time. And then, instead of I64, let's make it numeric. And we'll deal with the output type later. It's not quite correct. And let's get rid of these. Right, and in here, so we're going to have to make a little helper function. So let's say fun abs on numeric chunked array. And we're going to take in some chunked array of type t. And we're going to return a chunked array of the same type. And what we're going to do inside, we'll just copy and paste what we did here. Now in Rust, if you just make a single statement, then that's just what gets returned from the function. I think it's fairly handy. Kind of wish we had this in Python, as well as a few other things. And then we're going to run that here. So let out equals abs on numeric chunked array CA. And then we can just return that. Now, what is the Rust analyzer telling us? And why can't I see it too well? I should have just used VS Code instead of trying to look smart. But in for a penny, whoops. In for a penny, in for a pound. Let's do this. So we're going to have to specify some bounds on t. Not every Rust type is going to implement apply values. So we're going to say that where p is a Polar's numeric type. Okay, that's one step forwards. But now, Rust isn't complaining about apply values anymore, but it is complaining about x.abs. Right, that's an issue. So what's the data type of x? So each numeric type, let's see if we can go to the definition. It's got a native type. So this is a native Rust type associated with each Polars type. So if we want to add a string, a type annotation here, it would be t native. So we need to make sure that t native implements .abs. And the way we can do that is by saying t native implements signed. If it's a signed type, then it definitely implements abs. All right, I'm not seeing any red. Cool, managed to live code this without VS Code. Fairly proud of myself. And yeah, let's, so we still need to do this. However, this part here of registering the output type, this only matters for lazy execution. Like your code will still work. It'll still give the correct result in eager mode if you don't set this correctly, but it's not recommended. You're really playing with fire. And even in eager mode, Polars might do some optimizations which might end up stabbing you in the back if this was not correct. For now, we'll just keep it like this, but then I'll show you how to set it correctly. Right, let's save. Let's go to the command line, mature in develop. And in the meantime, while it's compiling, let's open run.py. And instead of passing this one to abs I64, let's pass it to abs numeric, although we also need to define abs numeric on the Python side. So let's do that. Numeric. All right, that's all we need to do. Has it finished compiling? Okay, great. And let's see what happens. Okay, we've still got an invalid type. So let's go back to run. What are we doing? Okay, right, it's this one. This one also needs to be numeric. Still got an issue. Which issue? Oh, sure. So this one isn't, just because I called it numeric, doesn't mean it actually is valid for all numeric data types yet. Like we just factored out this function, but in here, we're still expecting just I64. So for now, let's just comment this one out. Let's just verify that it still works. Okay, so it still works, even though we made it slightly more generic. Now let's see how we can complete the process. Let's go to expressions.rs, and the input series, this one is untyped. It can be backed by any type. So we need to compare, we're going to use a match statement, and based on the input data type, we're going to decide what to do. So we'll say let s equals inputs 0, and then match s.dtype. Then, if we've got data type int64, then we're going to run this one. So s.i64 dot, oh wait, so this one gets the chunked array out. Then we're going to do abs on chunked array. Right, so like this we get a chunked array back, and then we're going to have to wrap it back into a series. So we're going to say dot into series, and let's assign here. Let's say let out equals that. Then let's also deal with float 64, and anything else is yeah, exactly. Anything else is left as an exercise to the reader. For anyone who did a maths degree, I hope that didn't bring back too many bad memories. And then finally, we're just going to return OK out.
Not a question, a suggestion maybe. This kind of function can be provided in the Firebase Polaris extension.
You could probably provide a macro to make this easier for people. Yeah, totally. This could be you. Yeah. You said you were, yeah, just, so let's just complete the story. If you have something like this, then, you know, if you have an expression like this expression, then, yeah, you can do expr.meta.treeFormat. And if I remember correctly, a big part of the reason it looks so pretty is thanks to a contribution by you.
Oh, this thing is a while ago.
Okay, yes. So, yeah, amazing work. Thanks on behalf of the whole Polars community. Thanks for having done that. So, yeah, providing utility functions might be the next thing.
Have a look. I can't promise anything.
Cool. All right. So, unfortunately, until we have those convenient macros, we are going to have to define a different branch for each one. Rust does want that the output type, that the type of out be known. So we start with something that's a series, which we need to then step into the chunked array territory and then step back out into series territory. And like this, each arm has the same type. Once we've done that, we can just wrap it in OK, and hopefully it'll work. Let's take a look. Mature in develop. Let's then go back to run.py, comment this one out, and let's see if now we're finally able to take the absolute value of floating point numbers. What a historic achievement. What's going on? Oh, well, thanks. Probably. Very attentive audience, just testing you. Why am I doing this? Okay, while that goes. And the output type, yeah, let's talk about the output type. For the output type now, we cannot just set one particular output type. We cannot just say that the output type is going to be int64 or float64 or something like that. The output type is going to depend on the input type. So we're going to have to define our own function, which creates the output type based on the input type. And it's not as bad as you might be thinking. Let's first verify that we're able to run what we've done so far. Okay, now we're able to take the absolute value of floating point numbers as well. So just to give you an idea of what's going to come next. So first thing we're going to do next is we're going to make this fully generic. So we're going to write a function which gets the right output data type here, so that even in lazy mode, we're going to have the correct data types. Then we are going to return to the initial motivating example, and we are going to get closure on this. We are going to see how to do this as a Polars plugin. Then I'd like to show you what I think is the super secret magic source of Polars plugins, which is that you can access crates.io. So this is like the Python package index for Rust. Just people upload all kinds of crazy things. And if you need to do something fairly customized, like here's something I needed to use for a client recently, just a fast offline reverse geocoder, it was almost trivial to expose this as a Python plugin. And you know that meme? What's that meme? Like meme boss congratulating me. Yeah, you know this meme. Yeah, it felt like that. Like this client was like, "Oh wow, this is amazing! You made it so much faster." And I was like, I just used somebody else's crate and I just registered it as a Polars plugin. And yeah, you're going to be able to do that too. So yeah, I'm going to show that. And it's now 11:52. We've got until 12:30. So with all of these things together, we're going to get close to the end. So then we can either take random requests from the audience, or there's an infinite number of other topics which we can cover. So it depends on how engaged the audience is.
I have a request.
Oh no!
The code was a bit small for me to see. Would you
Oh, sorry.
after the workshop?
Oh, yeah. I mean, in fact, most of the talk today, but with less commentary, you can find it here.
Oh, but I want to have a look at the code that you were matching the types.
Oh, sure, yeah, but you'll find that here in the chapter, how to do absolutely nothing. Essentially, I don't have a very long attention span. I get distracted very easily. So if you notice the occasional pun, I'm just trying to keep myself entertained. Like it's nothing more than that. Don't take it too seriously. I don't have comedic ambitions. Right, let's try to make the output type depend on the input type. And the output type is going to be exactly the same as the input type in this case. So same output D type. And this is going to take a slice of fields. I think it's called just field. Yeah. And it's going to return a Polars result of field. And what we're going to do is we are just going to return OK fields 0.clone. I think that's all we need to do. So in general, with Rust, anytime you're cloning, it's a bit expensive, but in this case, this is just something you're doing once at the top of the function. It's not something you're doing inside a for loop, inside a hot loop. So yeah, this is acceptable. If you find yourself calling clone within apply values, then you probably want to consider whether you might be able to write it in a different way. Right, we've got that. And then instead of output type, we're going to use output type func, I think it's called. And we're going to use same output D type. All right, here we go. So let's have it compile while we amend the example. Let's go to run.py, and we're going to, what are we going to do? Also, sorry, you said this was a bit small. Let's see if we can make it bigger. Is this better? Right, 3/4 of the way through the talk. Well, not very good at this. Right, where were we? Yeah, so we need to, I'm going to make this a lazy frame, .lazy, and then we're going to print result.collect, but we're also going to print result.schema. And yeah, let's verify that this is actually correct. It's finished compiling, and now, so the result looks correct, but also if we look at the schema, then abs numbers shows int64, and abs numbers f64 shows f64. So it's, if we look back at the code, it's been able to figure this out before collect. So before it's actually executed the query, it already knows what the correct data type is going to be because we told it. Now my throat is drying up, so I'm just going to take some water. All right, back in full form. Cool, so that was abs numeric. Now, next thing, let's take a look at crates.io. Yeah, there's a bunch of fancy things in here. Actually, I should stop myself. Before I go on to that, any questions about this one? Okay, people are excited about crates.io, presumably, so let's do that straight away. So I don't know if anyone's doing, if anyone's doing NLP stuff. I'm not, but if you are, then there are functions here available for this kind of stuff. The plugin I specifically used for the client is this one here, reverse geocode. It just uses this particular crate, and then it just like finds the closest city to a given set of coordinates. Sorry, throat's still a bit dry, speaking too much. I don't usually speak this much, all in a row. Okay, cool. So let's try to use this. Let's try to make a quick plugin which just leverages this crate, and then you can use it in your own work, leverage what other people are doing, and impress all your coworkers. That's the ultimate objective, really. So to do this, we're going to want to add this crate. Now, there is one file which I haven't showed you yet, which is cargo.toml, and this one contains all of our dependencies. So to add this one here, we're going to do, cargo add, what's it called? Stemmer. All right, it's already added. Now I'm gonna have to compile. This might take a little bit longer the first time. Maybe not, it's not a huge library. Okay, and then let's make our own function called snowball stem. So on the Python side, it's going to be exactly the same as before. It's also so snowball stem. Snowball stem, here we are. It's also element-wise. Right, after this we're going to do the motivating example one, which won't be element-wise. And let's copy stuff over from here. snowball stem. So output type is going to be string. The input is also going to be string. We can probably copy this one just from pig latinify. So let's do that. Then let's see how, so see the documentation. Really well-maintained library. All right. In that case, I'm going to have to consult my own tutorial to remember which one I used, which was how to create something else entirely. Ah, it's Rust stemmers, not stemmers. Let's add that. So let's go over to cargo.toml. Let's remove this one. It's fired. Rust stemmers. Okay, while it compiles, let's go over here and see what we're going to do. I might as well just copy it. We've got it here. So we're just instantiating a stemmer, and then for each value, we're just using it, just calling it. Sorry, mind if I step out to get a bit more water, please? Oh, just, yeah, thanks. Either there or in a bottle. Ah, wonderful, thanks. All right, so what we're doing might look smart, but we're actually just, where is it? GitHub, Rust stemmers. We are literally just doing what it says on the README. So let nstemmer, so stemmer.create, and then stemmer.stem. And then we just copy and pasted the pig latinify example, and we replaced the pig Latin logic with this stemmer. And there you go. Let's see if it actually works, if this lives up to its promise. Probably not. Failed to resolve. Okay, we need to do an extra use. Gonna have to insert this at the top of the file. Is it a bit happier now? Oh, mismatched type. Oh, it expected a series into series. All right, very good. Now let's compile and let's make an example. So if we have now, I don't know, lyrics, fearless, fearlessly, feared, 1, 2, 3, 4. Let's make a null value as well, just to be spicy. And now, if we add that here, so lyrics stemmed, snowball stem, let's put in lyrics. And we run it. Okay, looks like it worked. So fearless stayed fearless, but fearlessly became fearless, and feared became fear. So that's what the snowball stemmer does. It reduces some variations of words to some common ones, which then you can use to do classic NLP, assuming your company is okay with you doing classic NLP and doesn't want you chasing the LLM hype. Not that there's anything wrong with that, but yeah, that's a little superpower that Polars plugins can give you. You can access a whole crate of things that other people have created for you. And yeah, when people say, you can just use number, well, first of all, as we saw earlier, number doesn't deal with missing values. But second, can't do all of this stuff with number. So yeah, Polars plugins for the win. Now, I did say that we would do this example, and yeah, when I did this live in Germany, I set a 5-minute timer. But we're not going to do that today. Hope you're not going to make me.
Yes.
All right. 5 minutes.
It should be 4 because you've done it before.
Okay, 4-minute timer. Fun crowd. Wait, stop. I haven't finished describing the exercise. Okay. Let's just make a test file then. So we need 1, 2, 2, 2, 1, 3, 1, 2. Df is going to be pl.dataframe, file size 1, 2, 2, 2, 1, 3, 1, 2. And then we're going to print df.withColumns result cumulative resetting sum file size. Okay, so we've got exactly 4 minutes to get this file to execute. Right, my heartbeat is at about 230 beats per minute, but let's do this. So first things first, we're going to go onto the Python side, and we're going to register this in Python. So snowball stem, let's get rid of that. It's going to be cumulative resetting sum. Then I'm going to do the same here. Set is element-wise equals false. Let's go over to the Rust side. And let's call this cumulative resetting sum int64 output. And we're just going to accept i64 for now. Let's get rid of this logic. Then let out int64 chunked is going to be, so we're going to iterate over our input this time. And then we're going to say for each value, which might be missing and it might be not, we're going to apply this logic. We're going to say if it's missing, we just return the missing value. And if it's not missing, okay, we should probably say let threshold equals 5, and then let mutable running sum equals 0. So in Rust, everything is mutable. Everything is immutable unless you say otherwise. And we're going to say value plus equals running sum. But if, sorry, the other way around. Running sum plus equals value. But if the running sum has exceeded our threshold, then we're going to set the running sum back to the current value, and we're going to return the running sum. And then finally, let's collect and have a semicolon at the end. Right, I'm not seeing any red signs, so I'm just going to save extra hard. Okay, let's develop. Right, how are we doing for time? 1 minute and 45 seconds left. So maybe if we've got a typo, we've still got time to fix it. Maybe. It's okay, we can make mistakes. And so the output we're aiming for is like 135.23342. And let's run it. Does this match? 135. We did it! Okay. Thanks, everyone. Very kind of you. We had 1 and 11.
Do we have time to put the argument, like the threshold as an argument somewhere?
Sure, but maybe not in 1 minute and 11 seconds. Yeah, let's do that. That's a fantastic request. Okay, let's talk about how you can pass in keyword arguments, because so far we've only looked at plugins which take in expressions or things which are convertible to expressions. So let's do that. So to do this, we need to add quargs, so keyword arguments, and it's going to be, let's say, cumulative let's just call it quargs. And this is going to be a struct, so struct quargs, and we're going to have threshold is going to be an, let's say it's I32. And this, what's the syntax for derive? Let's see, probably going to get this wrong. It needs to derive serialize and deserialize, which we probably need to import. Oh no, we've got them. Awesome. And then we're going to say let threshold equal to quargs dot threshold. Okay, wait. Yeah, we need to be able to compare it to the values. So okay, whatever. Let's just do the cast here as I64. Then let's start compiling. Then let's go over to the Python side, and here we're going to have to set it. Threshold int. No, actually, let's not make it keyword argue only. Yeah, promise I'm not sick. Just throat dries up when I speak too much. And then we're going to want to pass quargs. So threshold is going to get threshold. Okay. Let's go over to run.py. And let's see if this runs. Okay. And you can modify that. Let's put this here. Let's make 2 results, one with 5 and one with 4. All right, so it did take effect. You see that here we reset when we went above 4, and here we reset when we went above 5. Cool. Does that answer your question? Cool. Awesome. So yeah, just to go over what we did. On the Python side, we need to decide on the API for the user, and that's probably going to be that the user just passes in an extra argument like this. Then, in the register plugin function, we need to pass in quargs. So this is a dictionary where we pass in the name of the keyword argument on the Rust side, and then the value which we're going to pass in from the Python side. Usually you'll probably want to make these the same. And then when we're inside expressions.rs, we need to pass in an extra argument quargs. Now, the thing with these Polars plugins is the signature cannot be just absolutely anything you want it to be. It needs to follow a very specific pattern which Polars expects. So it needs to be inputs, and then optionally you can also include quargs. If you try putting in like threshold here, Polars is going to complain that it got an unexpected symbol. And then quargs, this cannot just be of any type. It needs to be a struct. And it needs to be a struct which implements serialize and deserialize. So that's how Polars is going to get it to communicate between the Python and the Rust side. In here you can set threshold, you can set capitalize as a Boolean. It needs to be something that can be serialized or deserialized. Can be a vector, can't be absolutely anything, but I think you can get pretty far with this mechanism. And then, yeah, you can just access it like this, quargs.threshold. Clear enough? Cool. Looking pretty happy. And all right, it's 12:14, only 15 minutes left. So got a question from Joy.
Just to check, the serialize and deserialize, is that Rust built-in thing?
Well, it's outside of Polars. It's not standard library, but it's provided by the creator Surdy. And if you look at the cargo.toml file, it's there. We had to explicitly include it. But this is already present in the cookie cutter. It's not something you need to worry about adding. I'm impressed with the Wi-Fi, by the way. It's remarkably reliable. You see, it's already included. We also include polars, the Rust package. This is different from the Python package. And notice how we've got default features equals false. So the Rust package is absolutely massive, and a lot of the code is not included by default. So when you're making a plugin, you probably only want to use the parts of polars which you absolutely need. So start with just polars with default features equals false. And then if you find that something's missing, try to find out which Rust feature you need to activate in order to include that part as well. And if you need it, include it. This will keep your compile times down and your binary size down. But overall, the binary size is pretty good here. Like I've got a client for whom I'm running some things on AWS Lambda. We've got polars, we've got 2 plugins, Boto, S3FS, and some other relatively minor library, but it all fits within like the 250 megabyte limit of AWS Lambda. It's yeah, pretty cool how far you can get. Cool, thanks, Joy. Yeah, anyone else? Okay, we've got 3 questions, and I pointed here first. So let's start with Tom.
So for the dependency management with cargo, that's going to work really nicely with Rust. Like if you had a bigger project that needed some Python libraries, and you wanted to manage the requirements, you can't use poetry because it doesn't work for maturity. Do you recommend anything?
Right. Luca is the expert here on dependency management, so I'm going to hand this question over to Luca.
So you can't use poetry with this.
No.
You don't want to just use requirements.txt.
You cannot really use poetry with this because there's a section in pyproject.toml that's named build system. The build system specifies, basically tells you like it's a backend that it's meant to assemble like the Avengers, right? All the components to make a Python package. While backends like by 518 have to have like a certain interface, but poetry has one of its own, which is poetry core, and so it cannot just speak with other backends.
Cool, thanks. So in short, poetry just does its own fancy things, so you won't be able to just use poetry and do everything together. So I think what you're getting at is you need to separately specify your Python dependencies here and your Rust dependencies in cargo.toml. It's just something we're going to have to live with. So the person who asked this question, GitHub, here it is. Yeah, the person who just asked this question, if the Wi-Fi was stable up until now, okay, it's stable now as well, has actually written a polars plugin, I think starting from zero Rust knowledge. Yeah, starting from zero Rust knowledge, he was able to put together this amazing plugin. And yeah, this could be you. Curious to see what plugins come out of today's sessions. So yeah, well done, Tom. Give him a star. We had another couple of questions here. All right.
Do you support binary or higher order operations?
Oh, yes. So
Do you have a limit if you go higher?
I don't think there's a limit, but there is an example here about binary operations. So here's a way of just summing 2 series together. You can use the binary element-wise helper function or the binary element-wise values. Then there's a ternary one. And if you want more arguments than that, then you can just look into these, see how they're defined, just zip iterators together. Yeah, you can do it.
Do you have a massive combinatorial problem with dealing with numeric types of binary?
Yeah, you might want to write a macro, a few macros to simplify your life there, but yeah, it is going to get pretty complicated.
Like the build size, for example.
Oh, the build size, yeah, probably. But it's probably better than bloating up the polars library itself with all of these very customized features. Like if you need to make a massive plugin for your own use case, then yeah, the package size might increase quite a lot. But also, one nice thing about plugins is that they're really close to the metal. So if you're wondering about how something works, like apply to buffer, let's see what this does. You see, I just did go to definition, and this has brought me into polars itself. So what you could do is you can look at polars, let's say sum horizontal, and like this one just, it takes an arbitrary number of expressions and sums them all together horizontally. So you could go into the source code, see how sum horizontal is implemented, and then you can use the tricks from there to implement your own plugin. And if anyone's interested in contributing to polars itself, then I think plugins are a great way to get a lot of the prerequisite information ready, just because of how close to the metal it is. Writing a plugin is very similar to how you define an expression in polars itself. Right. Does that answer the question? Okay, great. I think we had one more question from this side. Oh, was it here? Sorry, yeah.
I just had a generic question. Like, well, this example is a toy example. I wonder how much do you improve in terms of speed by going to the low level? But in general, like, do you have any other examples that you had to go to the low level plugin and then improve a lot in speed?
Yeah, okay, cool. So it depends on what you're doing. So for this one here, when I did the talk, I had some backup slides because I didn't think the live coding would work, but it did. Like, a lot of people give the advice never to do live coding. I think this advice is incorrect. I'm going to make this very confident statement because, you know, what is this? Like with musicians, if they perform in playback, everyone criticizes them. They're expected to do everything live. And I think that it's okay as a speaker to also do things live. Not saying you have to, but I'm saying, like, you know, if you practice something like 10 times, chances are you'll be able to do it live. Like, have some backup slides in case the Wi-Fi doesn't work, in case your laptop melts down. But yeah, I really want to encourage people to do more live coding in talks. Anyway, so in this case, it was like a more than 10x speed up. But yeah, it depends what you're doing. So I actually got really interested in plugins when I wanted to upstream, I wanted to contribute business day functionality to polars. But one of the maintainers, he was like, no, I don't think this belongs in polars. So I was like, all right, I'm going to make a plugin. And this one does custom business day arithmetic, which is like, let's say you start with a date, like 3rd of April, and you want to add 5 business days. Like, this is virtually impossible to do. Like, if you're iterating over rows in Python, it's going to be an absolute nightmare to do this. Like, it's going to take literally forever. But if you can go down to the Rust level, each date, it's just backed by an integer. So then it's just integer arithmetic. You can get this, like, blazingly fast. Like, compared to doing this in pure Python, I didn't time it, but I expect it's probably like 100, 1,000 times better. In fact, I know from memory that the Pandas implementation of custom business day business arithmetic isn't vectorized, so you can compare with that. But yeah, it's going to be orders of magnitude better. And anyway, this plugin did prove to be somewhat successful. Like a niche of people did really like this functionality. So eventually, I was really happy about this. Eventually, I was able to get enough support that this is now part of polars itself. You don't need the plugin, but the plugin is still there for historical reasons and because it's a bit of fun. Cool, yeah, thanks for the question. Got 7 minutes left. Anything else we want to talk about? Any other requests? All right, Joy.
Could you show some kind of group by?
That's a fantastic question. I promise Joy is not a plant. Yeah, in fact, this lets me demonstrate the importance of is element-wise equals false. So let's try incorrectly setting is element-wise equals true in our cumulative resetting sum. And let's see what happens. Let's go to run.py. And now I'm going to add an extra argument, which is going to be group. So it's going to be, let's say, A. How many do we have? 3, 6, 8. B. Hope this is the same length. And what I'm going to do is, so first let's just print this one. And then let's do over group. So using over, it's kind of like you're doing a group by and then joining it back onto itself. Now, we would expect these to be different. Like if you're doing it in the over context, then it should respect the group boundaries. So let's take a look at what happens. I don't think we changed any Rust code, so we should be able to just run this. And let's take a look. It looks exactly the same. So we've got 1324, 1413, 1324, 1413. Yeah, it's exactly the same. So why is it exactly the same? And the answer is it's because I incorrectly set isElementWise equals true. If I set isElementWise equals false, then now, now here we've got 13523342, and here 13521452. So if you're going to use your plugin in a group by context, it's important to set isElementWise correctly. Because isElementWise, it's just an optimization that polars can use. So if it's element-wise, then it doesn't need to respect group boundaries, and it can just blaze through the whole column. Whereas if it's not element-wise, it needs to respect the group boundaries. It's a bit more expensive. So yeah, if you're doing this in a group by context, make sure to set isElementWise correctly. And if you're doing if you want to make a special group by aggregation, then when you register the expression, you're also going to want to pass the returns scalar equals a true argument. By the way, I got an issue yesterday in the cookie cutter about a bug with return scalar. Did somebody from here open the issue by any chance? Was it you? Yeah, this is a lesson in not updating things just before a tutorial. Essentially, first, yeah, just 18 hours ago, somebody opened a pull request adding like this returns scalar argument to the register plugin, and I just got really excited. I was like, yeah, ship it, gave this person a GIF. But then, yeah, just the evening before my tutorial, someone is like, oh, wait, this actually breaks the built-in example because it doesn't have a default value. So, I mean, fairly simple fix, just add a default value of false. Anyway, don't update your packages the day before giving a tutorial. Learned this the hard way. Cool, we've got 2 minutes left, so I think we're pretty much at time. I think you've been an absolutely wonderful audience. This has been so much fun to do. Thank you so much for engaging and for being such a fun audience. You're all amazing. Hope you enjoy the rest of your talk. Write an amazing plugin. Yeah, thank you so much.